Hello everyone, today we're going to be doing some proofs involving circles. And our goal is going to be able to prove that a point is either inside, outside, or on the circle. So first thing we're going to do is we're going to write the equation of the circle in standard form if it's not already given to us. So we should already know how to do that. And then once I have my standard form equation, I'm going to plug x and y, the values that I'm given, into the equation. So there's three different scenarios that could happen from there. So when I plug that in to the left side of the equation, if the thing that I get is greater than r squared, that's telling me that my distance is greater than the radius, so the point is going to be on the outside of the circle. When I plug this in, and if I get something less than the radius squared, what that's actually telling me is that the distance is less than the radius. So that means that point will be on the inside of the circle. And then when I plug that in, if it's the same as the radius squared, what that tells me is that my distance is the exact same as the radius. So what that means is my point is going to be on the circle. So let's take a look at some examples of this. So here's the first one. It says prove that the point -4, 3 lies on inside or outside of the circle with the equation x minus 3 squared plus y minus 2 squared is equal to 7. So what we're going to do here is we're going to take this -4 and we're going to put it where x is. We're going to take this 3 and we're going to put it where y is, and we end up with this equation. So we have -4 minus 3 squared plus 3 minus 2 squared is equal to 7. And then just simplify. All right, so -4 minus 3, that's going to be -7 squared plus 3 minus 2 is 1. So I've got 1 squared is equal to 7. That ends up being, if you add these two things together, you're going to get 50 and then 7. Okay, so what we know is that this number is not equal to 7, but it's actually greater than. So since it's greater than 7, this point is going to be outside the circle. And that's it. All you have to do is plug it in and see what happens. Here's another one. It says prove that the point 4, 1 lies inside, outside, or on the circle, whose center is at 0, 1 and has a point 0, 5. Okay, so on this one, we actually need to write the equation of our circle. Okay, so two things I know is that my center is at the point 0, 1, and I have this point up here at 0, 5. That's on the circle. So I have a circle that's going to look something like this. It's not a perfect circle, but we get the point. Okay, so if my center is at 0, 1, the left side of my equation is going to be this: x squared plus y minus 1 squared. Okay, now I'm going to use this picture over here to find the radius. So the radius is from the center to that point, and those points are 4 apart. So the right side of the equation is going to be radius squared, which is 16. And now we're just going to take our x value, 4, and plug it in for x. We're going to take our y value, 1, and plug it in for y. And I'm always going to use parentheses when I plug something in like this. So I'm going to have 4 squared plus 1 minus 1 squared is equal to 16. So 4 squared is going to be 16 plus 1 minus 1 is 0, and 0 squared is 0, equal to 16. Simplify that, you get 16 is 16. Okay, so since this is equal, these two things are exactly the same, all right? We know that the point is on the circle. And that's it there. We know that this point is on the circle because both sides of my equation are equal to each other. Okay, here's one more example. This one says, prove that the point 1 root 7 lies inside, outside, or on the circle centered at the origin, and it contains the point 0, 4. Okay, so real quick, let's just draw a quick sketch of what this looks like. So my center is actually at the origin, which is 0, 0, and then I have the point 0, 4. So 1, 2, 3, 4. So we have this point here. So we end up with a circle that looks something like that. Okay, so if my center is the origin, the left side of my equation is this, x squared plus y squared. Okay, looking at this picture, it's pretty easy to see the radius. Our radius is 4, okay, because the distance between those points is 4. So 4 squared is going to be 16. Okay, so now we're just going to sub these points in. So this 1 is going to go where x is, and this root 7 is going to go where y is. So here's what that looks like. I've got 1 squared plus root 7 squared is equal to 16. Okay, so when I square those, I end up with this 1 plus root 7 squared is going to be 7 is 16, end up with 8 equal to 16. That's not true. What we do know is that 8 is less than 16. So what that tells us is that the point is inside the circle. Okay, and the reason why is because what we just showed when we did this equation is we're showing that the distance from the center is less than what the radius is. Okay, so since this distance is less than the radius, this point is gonna be somewhere like right around, let's see, root 7 is gonna be right about here. So that's where that point is going to be, okay? And that's it. That's all you have to do to prove that a point is inside, on, or outside of the circle. Just use the equation of the circle and interpret from there, okay? So please go check out the assignment on Canvas. Let me know if you have any questions. Have a great day.